Okay, so I've noticed that a lot of people are making similar mistakes for this day one stuff that we talked about on points, lines, and planes. So what I'm trying to do is I'm making this video as kind of a reteach of that first day. And this should not be very hard, but I'm going to try to make it as simple as I can. So I'm just reteaching that first day of points, lines, and planes. Just very simple. So, definitions of each, which were covered earlier, but a point is a location with no size. It usually looks like a dot, and then you call it with a capital letter. A. Or point P. Or point Q, just whatever. Okay? That's one single location. When you have a line, you have a series of points that extend in two opposite directions, and there's no thickness. So it's like you start with one point, then you add another one, and another one, and another one, until you get this line, and it extends in both directions. Okay, and usually there are 2 points on there that help you identify what you're talking about. I won't talk about naming in just a little bit, but you need 2 points to name a line, 1 point for just a point, and then when you go to a plane, it's a flat surface with no thickness, and usually it has a parallelogram-esque shape, and it extends infinitely in all 4 directions. So up, down, left, and right. It's usually kind of slanted like that. And we'll talk about naming in just a second, but that's the definitions. So point's a location, a line is a bunch of points, and then a plane is a flat surface with a bunch of lines and points inside of it. Okay, naming. I'm going to stress here the importance of naming. It is so important to name things appropriately in geometry and how to label things correctly. Okay? So as said earlier, a point is usually just a dot, a location, and with a capital letter beside it. That's not that hard. On a line. Now, remember, there's infinitely many points along this line. I've just picked out 3 of them. Let's just assign them. That was supposed to be a D. My point went away, so I'm going to put it back. Let me do it on top here. Okay, I've just labeled 3 points on this line. There's infinitely many, I just wanted to pick out 3. If I want to name it, I can just use 2 of those labeled points. So I could say D. Let me put that where we can see it, because that's not going to work right. I could say D, E. And to tell me it's a line, I put that on top. I literally draw a line on top of the 2 letters. That tells me we're talking about a line. Okay? If I just, let's do another one. Let's say I did E to F. If I just do that with no arrows, that's technically a segment, which we talked about yesterday. Okay? With no arrows, it's a segment. If you do 1 arrow, it's a ray. 2 arrows makes it a line. So you gotta be careful and make sure you put the correct things on top of your letters. Now, if you'll notice, there's a lowercase letter over here. If you so choose, why did I write cursive? Lines can also be named by that cursive letter, or lowercase letter at the end. Okay, so it's either this or something like this. And you can also flip these around. EF, well, that's the same line as if I just went FE. That's the same line. Or I could do FD. Your naming possibilities are about endless there. So remember, it's 2 letters with a line on top, or line lowercase letter. Let's talk about a plane. To name a plane, if you're going to go with this letter notation, you have to use 3 non-collinear points. Okay, so let me name these. Let's do J, K, L, and M. Okay, so if I want to name this plane, I got to make sure I pick 3 points that do not fall on the same line. So I could say plane J, K, L. That's a plane. That's a name for a plane. Or plane JKM. Okay, you have to make sure that there are 3 non-collinear points. In other words, it's 3 points that cannot be drawn on the same line. Okay, that's with the letter notation. If you'll notice there's a capital letter in this corner, we can also name a plane by that capital letter. Just plain T. Okay? Lots of options there. That's naming. Naming is so super important. You have to be precise. And that's one thing in geometry you'll notice. You have to be precise or otherwise people don't know what you're talking about. Alright. I'm going to cover 4 postulates here really quick. And what a postulate means is it's something in geometry that we know is true and we take it to heart. Like we don't necessarily have to prove it. Later we'll talk about theorems, and theorems you actually have to prove. Okay, so a postulate you don't have to prove, a theorem you have to prove. Okay, so this first postulate is about 2 points in a line. The first postulate says if I have any 2 points somewhere, I can draw a line between them, connecting them. Okay, so any 2 points, I can draw a line through them. We want to label them. Second postulate is about 2 intersecting lines. I'm going to give me some labels here. Alright? So, postulate number 2 says if 2 lines intersect means they cross. If 2 lines intersect, they will intersect at exactly 1 point. Okay, so in this example, we would say QR, line QR, and line ST I'm going to abbreviate intersect at point U. Okay? So 2 lines intersect at 1 point. If planes intersect, now you can have intersecting planes. Planes intersect at a line. Okay, so I'm going to go back up here and just see. 2 intersecting lines. 2 lines intersect at a point. 2 planes intersect at a line. So notice in this picture here, I got one plane kind of going flat and one kind of cockeyed, and they're intersecting right there. So let's name those. We would say plane. Let's use the capital letters. We could say plane P and Q. I think it's Q. Yeah. Intersect at the line AB. Okay? Now, if you really wanted to use the letter notation, for P, you could do D, A, B. Dab. That's funny. DAB, and then for plane Q, you could do CAB. You could do cab. If you wanted to use the 3-letter notation system. Either way works. Now the last postulate is about 3 points in a plane, which says if you have 3 non-collinear points, so this has to be non-collinear. Any 3 non-collinear points, you can draw a plane. So on this box, if I looked at the top, I could say G, H, and M. That top, G, H, and M, I can make a plane there. Or, look at another one, I could do L, M, N. There's a plane, either side. Now here's something else I want you to notice. The 2 planes I did were on the outside of the box. You can actually kind of go through the box. So let me show you. If I do L, M, J. Remember the postulate says 3 non-collinear points. Well, clearly L, J, and M, L, M, and J are not linear. They're non-collinear. Sorry, got tongue-tied. Well, the only other point I could use would be K. So it's kind of like it's called a diagonal plane. It's going right through the box. Okay, you can do that. That would be called a diagonal plane. Alright? Now, what I'm going to do here with this practical example is I'm just going to make some stuff up and just point some stuff out to you. Okay? So, I'm just going to highlight a line. This line right here. If I wanted to name it, I don't have a lowercase letter out at the end to label it by, so I have to use the 3-letter system, or 2-letter system for a line. Excuse me, 2 letters. So one example, I could say E, EB. I could say ED, or BD. Or even the backwards, I could go DB, DE, BE. There's all different kinds of ways to name that line. Okay? What about the plane? The actual plane itself? Well, I could call it plane Q. Or I could use 3 non-collinear points. So, I could do D, C, B. Or you could put that in alphabetical order if you wanted to do B, C, D. Or I could do EAC. Or ABD. I'm having to stop and think, that's why I'm pausing. Notice what I can't do. I'm going to do this in red. I cannot do this. I cannot say that's a plane. You're thinking, why not? It's inside the plane. It's not an appropriate name for the plane because E, B, and D all lie on the same line. They're collinear. That doesn't necessarily guarantee I'm talking about a plane. So if I swap this D out, oops, let me put it all back. If I really wanted to use E and B, I'd have to use something like C or A. I have to use something that's not on the same line as these two. That guarantees me I go this way or that way and I cover the whole plane. Okay? Alright? These two lines right here, line AC and line ED, they intersect at B right there at that point. Okay? Now notice something else. See this big line through here? We would call that line FB because F and B lie on it. That line is intersecting the plane. So we could say line FB and plane Q intersect at B. So just a line and a plane can intersect itself too, or intersect themselves. Okay, let me think of anything else that we could talk about from here. Okay, I think that's enough for points, lines, and planes. That should be helpful. So remember, a point is one letter. A line is two letters with a line, two capital letters with a line on top, or a lowercase letter like P. A plane has to be three non-collinear points. So let's just assume those are non-collinear, or a capital letter like M. So that's lower, upper. Okay? So points, lines, and planes. And then I'll throw it in here just real quick. From any line, put some points on here. Okay, so there's me a line with 4 points. If I wanted to make a segment has a start point and a stop point, and it's all the kind of points between them. So if I wanted just to go from B to C, it'll be that set right there. I would put the 2 letters and just a bar. No letters, no arrows, no dots, no nothing, just a bar. This bar means segment. Okay? If I wanted to talk about array, let me do that different color. Hang on, let me do that different color. If I wanted to talk about array starts at a certain point and then goes forever in one direction or the other. Now I went left here because I've got letters to pick from. So if I want to start at D and make array, I could go from D to C. And array, you put 1 arrow on the end. This first letter should always be the endpoint for array. Okay? And then there's something called opposite rays. Opposite rays have to share an endpoint. So let's say I want the endpoint to be C. I could do array this way and then array this way. So we could say CD and CB. opposite rays because they share that endpoint. Okay, that was just an overview of, real quick, over points, lines, and planes, segments, rays, and opposite rays. I hope this video helps. If you're still having trouble, please contact me. Please contact me. If you need some help.